The Invention of Science. Written by David Wootton. Introduction. A world waiting for new eyes. Before science became a disciplined pursuit, the world seemed governed primarily by inherited wisdom. Knowledge flowed downward from ancient texts, echoing the authority of long-dead thinkers whose words were treated as anchors of certainty. Curiosity existed, of course, but it often took a cautious form, constrained by tradition, theology, and the expectation that truth had already been discovered centuries earlier. In this environment, observing the world directly, rather than simply interpreting ancient sources, was not yet the foundation of intellectual life. Yet beneath this surface of stability, quiet shifts were underway. Adventurers sailing across new oceans encountered landscapes unknown to the ancients. Artisans tinkered with lenses, pumps, and gears, discovering that materials did not always behave according to old claims. Merchants and navigators required more accurate maps, more reliable instruments, and more precise measurements. These pressures whispered that the world still held secrets unacknowledged by those relying on ancestral authority. It was not that people abruptly lost faith in tradition. Rather, increasing evidence suggested that tradition could no longer encompass the full range of human experience. This emerging tension changed the atmosphere of learning. Students began questioning whether ancient explanations could account for phenomena observed with new tools. When a telescope revealed mountains on the Moon or moons orbiting Jupiter, the implications stretched far beyond astronomy. The very idea of what counts as evidence shifted. Seeing with one's own eyes began challenging what had long been accepted on faith. In workshops and observatories, in private studies and public squares, a subtle rebellion unfolded, not against religion, but against intellectual stagnation. The world was becoming larger, more complex, and more resistant to inherited categories. New instruments allowed people to witness previously invisible realities: microscopic structures, astronomical distances, atmospheric pressure, and chemical transformation. As discoveries accumulated, an older worldview strained under the weight of new information it could not absorb. A space emerged in which a new way of thinking could take root, a way that did not presume that truth belonged to the past, but that truth awaited discovery in the present. Chapter 1. When Discovery Became Possible. The idea of discovery, in the modern sense, did not exist until surprisingly late. People traveled, mapped, and described regions beyond their homelands, but the language of discovery was muted. New lands were found, in a geographical sense, yet natural phenomena were rarely framed as revelations overturning old knowledge. To overturn, one must first believe that knowledge can change. This shift required both intellectual humility and confidence. Humility to admit that the past was incomplete, and confidence to assert that the present could surpass it. In the 16th and 17th centuries, this mindset began to crystallize. Sailors charting unfamiliar continents realized that the world did not match classical texts. Herbalists studying plants from distant environments observed properties unrecorded by early physicians. Astronomers tracking celestial bodies noted irregularities that ancient models could not explain away. Slowly, the notion that the world contained truths unknown to the past became acceptable, even thrilling. Naming this process was itself revolutionary. Words such as fact, evidence, hypothesis, and experiment acquired sharper meaning. The language of knowledge expanded to accommodate observations that demanded verification rather than reverence. New terms like discovery and invention indicated not only objects created or found, but insights achieved. It was as if culture had created the conceptual scaffolding necessary for observation to become investigation. This conceptual reorientation also changed expectations regarding authority. Scholars and thinkers began to insist that claims must be demonstrated, not merely argued. Instruments like telescopes and microscopes provided demonstrations independent of their operators' reputations. A new kind of trust was emerging. Trust not in the person, but in the method. Once this shift occurred, discovery became not a rare event, but an ongoing process. The world transformed from a completed text into a field of unanswered questions, waiting for exploration. As the idea of discovery became central to intellectual life, it also reshaped identity. A discoverer was no longer merely lucky. He was skilled, equipped, persistent. Discovery became a vocation, something requiring dedication, instruments, collaboration, and systematic inquiry. Europe's intellectual landscape had begun to tilt away from the authority of the past and toward the possibility of new knowledge. Chapter 2: Instruments that changed the imagination. Modern science did not arise from ideas alone. It emerged from the marriage of thought and instrument. The telescope allowed people to see beyond the reach of unaided vision, revealing celestial bodies that contradicted ancient cosmologies. The microscope split open a new world, exposing structures of life too small to imagine. Air pumps, barometers, thermometers, and lenses demonstrated that nature behaved according to measurable laws, even when those laws defied intuition. Instruments did not merely extend human perception, they redefined what counted as real. Before these tools existed, debates about nature were often philosophical disputes, resolved through rhetorical skill or textual analysis. With the advent of precise instruments, nature began to speak through measurement. Scales, balances, and calibrated devices offered answers that did not require persuasion. A reading on a barometer or a predictable behavior of mercury under heat carried authority that no ancient text could override. Yet instruments also required new habits of interpretation. They were not self-explanatory. A telescope's image could be dismissed as an illusion unless observers agreed that the instrument provided trustworthy evidence. Acceptance came slowly, through repeated demonstrations, shared observations, and the emergence of communities committed to systematic verification. Scientific societies, correspondence networks, and experimental groups became essential. Knowledge was no longer produced in isolation, but through collective scrutiny. These tools reshaped imagination as well as understanding. The idea that nature could be broken into components, measured precisely, and recombined under controlled conditions changed how thinkers envisioned the world. Nature became dynamic, lawful, and open to interrogation. Phenomena that once seemed mysterious, lightning, magnetism, heat, began to appear accessible through experimentation. The boundary between the visible and invisible blurred, inviting investigators to search for underlying mechanisms rather than surface appearances. In this new environment, the instrument became a symbol of intellectual transformation. It represented not only power over nature, but humility before evidence. With each new device, the world expanded. With each measurement, certainty shifted. And with each experiment, the conviction grew that reality was more surprising, intricate, and beautiful than inherited knowledge had allowed. Chapter 3: A New Language for Truth. As instruments transformed perception, a new vocabulary of truth emerged. Words that now seem everyday once carried radical implications. Fact originally implied something made, a human construction, not an objective observation. Over time, the meaning inverted. A fact became something that existed independently of belief, demanding acknowledgement rather than interpretation. This shift reflected a broader transformation in how knowledge was understood. Similarly, evidence gained its modern sense only when investigation moved from authority to observation. To speak of evidence was to appeal not to tradition, but to nature. It implied that knowledge rested on foundations accessible to anyone willing to look carefully. This democratization of truth eroded the monopoly previously held by scholars trained in classical texts. Ordinary artisans, sailors, and instrument makers could participate in discovery because evidence no longer required mastery of ancient languages. It required skill, precision, and integrity. The word experiment also evolved. It once referred to practical trials, often performed without theoretical implications. But as natural philosophy matured, experiments became structured inquiries designed to isolate variables, test hypotheses, and produce repeatable results. They shifted from demonstrations of known truths to investigations aimed at uncovering the unknown. Once experimentation acquired this meaning, it became central to scientific identity. These linguistic transformations were not mere semantic shifts. They shaped how thinkers approached the world. A culture that adopted words like data, laws, and method became capable of asking questions that would have been inconceivable earlier. New vocabulary allowed new thoughts to form, much as new instruments allowed new observations. The very concept of nature changed from a static order to an arena of dynamic processes waiting to be decoded. Language gave science the structure it needed to become self-sustaining. Concepts such as progress and innovation framed discovery not as accidents, but as expected outcomes. With a vocabulary oriented toward the future, scientific inquiry gained a sense of momentum. Once people believed that new knowledge was both possible and desirable, discovery accelerated beyond anything earlier centuries could have imagined. Chapter 4. The Transformation of Authority. When new vocabulary and instruments entered intellectual life, traditional authorities came under strain. Scholars had long relied on classical texts, interpreting them with care and reverence. But as observations contradicted ancient claims, reverence became difficult to justify. The idea that knowledge might be provisional, corrigible, and open to challenge shook the foundations of inherited wisdom. The shift did not occur through rebellion alone. It developed gradually, through the accumulation of anomalies. Observations that violated established theories might first be dismissed, then tolerated, then acknowledged, and finally integrated into new frameworks. This slow erosion of certainty eventually produced a cultural transformation. The belief that nature, not tradition, is the ultimate source of knowledge. Print culture intensified this shift. Ideas circulated faster, reached wider audiences, and invited public debate. Discoveries once confined to learned circles spread across continents. Pamphlets, treatises, and scientific journals created intellectual spaces where claims could be contested openly. Authority fragmented. No single institution or tradition could control the flow of ideas. Instead, credibility came from clarity, method, replication, and coherence with observed reality. Universities, long guardians of classical learning, adapted unevenly. Some resisted the new science, defending traditional curricula and methods. Others embraced the emerging worldview, integrating mathematics, experimentation, and observational disciplines into their programs. The rise of academies and scientific societies further redistributed authority, creating parallel networks of investigation independent of older institutions. This transformation encouraged a new attitude toward error. Mistakes were no longer seen as failures of character, but as inevitable steps toward truth. A culture willing to learn from error embraced intellectual risk, experimentation, and the possibility of overturning even deeply entrenched beliefs. The authority of the past gradually gave way to the authority of method, a foundation not immune to challenge, but strong enough to support continuous inquiry. Chapter 5. The Birth of the Scientific Self. As ideas, instruments, and authority structures shifted, so too did the very notion of the investigator. The scientific self, a person committed to observation, precision, skepticism, and collaboration, emerged as a new cultural identity. This figure valued patience, discipline, and the willingness to follow evidence wherever it led, regardless of personal beliefs or societal expectations. The ideal of objectivity blossomed within this new identity. To be objective was not to eliminate perspective, but to cultivate habits that minimized personal bias. Observers learned to describe phenomena in standardized terms, to record data carefully, and to compare results openly. Trust in science became trust in the procedures, not in the personalities of those performing them. This transformation required a new kind of humility, the recognition that truth emerges not from certainty, but from methodical doubt. At the same time, the scientific self possessed a creative dimension. Formulating hypotheses, designing experiments, and imagining unseen mechanisms required imagination as much as discipline. The emerging culture of discovery treated curiosity as a virtue rather than a distraction. The scientist became an explorer of the invisible, someone who navigated realms beyond ordinary perception using both reason and ingenuity. This identity reshaped social structures. Laboratories replaced private studies. Collaboration took precedence over solitary contemplation. Experimental results gained credibility only when repeated by others. A communal enterprise emerged, governed by shared norms and expectations. Science became not only a method, but a community bound by commitments to openness, rigor, and continuous questioning. Thus, the scientific self bridged two worlds, the world of disciplined inquiry and the world of creative insight. It required both imagination and restraint, daring and patience. In cultivating this identity, the early scientists laid the psychological foundations for modern research culture, a culture that continues to evolve but still draws upon the ideals forged during this transformative period. Chapter 6. A New World of Time, Space, and Knowledge. As scientific thinking matured, it reshaped how people understood reality at the deepest levels. Space became measurable, predictable, and governed by mathematical laws. Time, once tied to seasonal rhythms or theological narratives, became a dimension that could be quantified with unprecedented precision. Knowledge, once rooted in ancient authority, became dynamic, cumulative, and open-ended. The idea of progress, now central to science, took hold. People began to believe that future generations would surpass present understanding, that mysteries would be solved through inquiry rather than revelation. This belief fostered optimism, but also responsibility. If the future could be improved, then ignorance became a challenge to overcome, not a condition to accept. The pursuit of knowledge thus acquired moral weight, encouraging individuals and institutions to invest in education, research, and innovation. Technological applications followed naturally. Understanding air pressure led to improved pumps. Studying optics led to better lenses. Analyzing motion led to advanced instruments for navigation and industry. Knowledge and technology formed a feedback loop. Discoveries enabled new tools. New tools enabled further discoveries. The world became increasingly shaped by the fruits of inquiry, altering agriculture, medicine, manufacturing, and communication. This transformation extended into the cultural sphere. The belief that nature operated through universal laws encouraged thinkers to search for patterns in society, economy, and politics. While these analogies were sometimes misguided, they expressed a growing conviction that the world, in all its complexity, could be studied systematically. Intellectual ambition expanded, embracing not only the physical world, but human affairs. By the end of this transformation, Europe had entered a new intellectual era. The world no longer appeared static or predetermined, but dynamic and discoverable. Reality invited questioning, measurement, and experimentation. The boundaries of what could be known widened dramatically, and with them, the horizons of possibility. Conclusion. The transformation that reshaped European thought did not occur overnight. It emerged from countless small shifts, new instruments, new concepts, new forms of authority, new identities, converging over generations. Together, they produced a worldview that treated discovery as central, experimentation as essential, and truth as something built through collaborative inquiry rather than inherited tradition. This revolution laid the foundations of modern science. It introduced the idea that knowledge advances, that mysteries yield to investigation, and that methods, rather than individuals, ground certainty. It replaced reverence for the past with confidence in the power of observation and reason. The world became a place governed not by unquestioned authority, but by patterns legible to disciplined inquiry. Yet this transformation was not merely intellectual. It reshaped how people understood themselves as observers, investigators, and contributors to an ongoing search for understanding. It fostered humility before evidence and respect for the complexity of nature. And it set in motion a cultural trajectory that continues to shape modern life, from technology and medicine to education and philosophy. In tracing this development, the story reveals how profound the invention of science truly was. It was not just the creation of new tools or theories, but the birth of a new way of seeing the world, a way that invites every generation to push the boundaries of understanding and to imagine what more the universe might yet reveal. Thanks for listening.
Did you enjoy this book's summary? Got ideas on how we can make it even better? Drop us a quick note. We're always listening and learning from you.